Hear that? It doesn't sound good. And it doesn't feel good either. These wire wheels wreak havoc on these small angle grinders, likely due to the imbalance in the wheel, leverage and tendency to press onto the workpiece. There is play in the shaft. And that's new, the housing's cracked. Shit, it really is coming apart. The replacement bushing I fitted wore out, the previous one cracked. I had roller bearings go bust and even bearing housing come apart. Time to make a proper gearbox, made of steel and ball bearings. First I make the flange that couples the gearbox to the motor. I set the X and Y axis DROs to drill the holes for the 4 mounting screws and motor shaft. And they fit okay. I weld a piece of flat stock to thicken the flange. The motor shaft hole is drilled through, widened and tapped. This allows me to mount the flange onto a stub arbor and turn a spigot that fits in the motor housing. The spigot centers the flange in the housing and the screws retain it in place. A shallow counterbore hole is opened up to seat the motor bearing retainer. Here it is. Now I need to bore a seat for the bearing. The flange is held to the chuck using this retaining plate. The stub arbor is used to dial it in. A DRO is used to set the depth of the bore, then the automatic carriage stop is set to trip at this location. The bearing retainer screw holes were drilled and tapped. This piece of hollow section shall become the gear housing. A hole was first drilled through, then a cutout is made to fit the grinder's output bearing housing. The hole opposite to the cutout is used to mount the housing on the stub arbor. The cutout shall be open to fit the bearing housing. And the bearing housing is introduced to its new home. Another cutout is made for the motor output gear. And now it's starting to look like a gearbox. The bearing block shall be made from this metal cube. A hole is drilled and tapped so that the block can be fitted on a stub arbor. A boss is turned at one end. It shall serve to hold the bearing block in the housing. The boss is now used to bore a pocket for the two bearings. Again, the DRO is used to bore to the required depth. Two small holes are drilled to eject the bearings. A partially pressed bearing is used as a guide in threading the boss. Two bearings are pressed into the housing. Two holes are drilled in the housing, one shall act as a key to prevent rotation, the other for the lock button. The holes are then transferred to the housing. The lock button shall work like so. This high tensile steel screw shall become the lock pin. I need to make a groove for a C-clip. Works perfectly. I pressed a pin in the bearing block to key it to the housing. The housing was tacked to the flange to test the gear engagement prior to welding. Now I have 4 problems. I need to address the bow in the hollow section, seal the housing and prevent it from flexing and reduce the internal volume to a minimum. Welding the sides would warp the housing. A piece of wood, with a cutout for the internal solves these problems nicely. The wood was milled slightly over the internal dimensions of the housing, is pressed in. I drill and tap a hole on either side for a handle. I drill a series of ventilation holes in the flange. Now to assemble the thing. Works okay, no strange noises. A nice dollop of grease and it'll be good to go. I gave it a good workout and the shaft feels solid. Time will tell, but leagues better than what is out there.